Okay, so today we are dealing with 9.3a, and we are moving on from arithmetics series. We are doing now geometric series. A little reminder, arithmetic series had the same change, same rate of change in each and every single one. To what the difference between arithmetic series and geometric series. Geometric series isn't the exact same in each and every single one. However, it does have the same rate of change. Before, you would add or subtract the exact same number each time because the arithmetic series is linear. This time we are either multiplying or dividing by the exact same number to check in arithmetic series. So each succession of numbers should be multiplied or divided by the exact same numbers if it were to be an arithmetic series. So no, a geometric series. I'm sorry, geometric series. So let's try this out. So let's say we had 2 comma 4 root 3, 8 root 3, and 16 3 root 3, and so on. Well, let's check. From here, we are going to always assume 2 is going to be our a sub 1, our very first value. So from 2 to get to 2 root 3, I would have to multiply by 2 and divide it by root 3. And that gives me 4 root 3. So if all of the other numbers, if I multiply by 2 and divide by root 3 and I get the same numbers, then it should be a geometric series. So here, 4 root 3 times 2 divided by, wait. This is 8/3. Sorry, here. This is actually 8/3. Let's see here. 2 root 3. So this gives me 8 divided by 3. It's working so far. And then the last one, 8 over 3 times 2 root 3. That gives me 16 and 3 root 3. So this is a big yes. It is a geometric series. Now let's get into the formula of a geometric series. It doesn't have a finite formula just like the arithmetic series, but the geometric series kind of looks like this. It's a plus a sub r plus a sub r squared plus a sub r cubed, and so on and so on. So let's say we have a sub 1 is given as 6, and r then is given as negative a half, and I want to find ace of 3, right? Here in ace of, if you notice in the first value, you aren't dealing with r to the 1 power. You aren't dealing with r. R doesn't come until the second power. So when we're dealing with ace of 3, I want to first multiply, let's say 6 times my negative 1/2. And we aren't dealing with r to the third power. We are dealing r to the second power. So we take our number and we do multiply that, subtract 1, which is 6 times negative 1/2 squared, which is that makes 6 times 1, and then that's 6 over 4, which is the same thing as saying 3/2. So once again, the formula that if I want to find a certain n term to that, it's a times r, and my n minus 1 would be my formula to find any particular value. Let's do another example of that. So let's say a sub 1 equals 1, my r equals e to the negative x, and my n equals 8. So I just got to plug it into my formula. This is 1, r is e to the negative x. Just keep that whole thing in. And then we do 8 minus 1. That is e to the negative x to the 7th power. And as we know, an exponent is you just multiply. So this is e to the negative 7x. Let's find let's say we are given a set of numbers and we need to find a certain term. So let's say we were given 5/3, -1, 3/5, and so on. And we want to find the value of a sub 8, or the 8th term, or 8th term. First things first, we need to find, we have a sub 1. A sub 1 is 5/3. We need to find r, right? So we need to see what times 5/3 would make that -1. When we think about times x would equal -1, right? Or in this case, not x, r. So here r should equal what? -3/5. So now we can just plug that into our formula to find our any of our values. So scroll that back up to our formula. Our formula is a times r times n minus 1, n being 8 in this case. So a here is 5/3. So we have 5/3 times r. We found that to be -3/5. N minus 1, that's 8 minus 1. So this is 5/3 times -3/5 to the 7th power. Okay, plug that into our calculator. So -3 to the 7th power times 5 for the numerator. I get -10935 for my numerator. My denominator, I have 5 to the 7th power times 3. I get 234,375. And here I can tell this number is too big for my ABC bun, so I can try to reduce this a little bit more. I know they have both 5, so I can reduce a 5 and a 5 in the numerator and the denominator. So I get -2187. Divide the denominator by 5. I get 2, 3, 4. Oh, that's not divided by 5 here. Let's divide that by 5. 2, 3, 4, 3, 7, 5. Divide that by 5. I get here 46875. I also noticed that there was a 3 in my numerator and denominator, so I'm going to divide both the numerator and denominator by 3 also. So that gives me -729 for the numerator and 46875. Divide that by 3. I get 15625 in the denominator, and I doubt that it will be simplified even further. So that will be my answer.